This video goes with Kuta handout, and it's marked Kuta handout number 17, but I made a mistake. It really should be Kuta handout 18, so students can make that adjustment. A couple things we're doing. We're trying now to find three things on this handout. We're trying to find the volume of geometric shapes that come to a point. So our geometric pyramids and cones. We're also simplifying some expressions, and then we're doing some solving equations at a higher level. So I'll give an example of all three of those. The two examples I'm going to give here would be number 3 and 4. So for number 3, the volume formula for any shape that comes to a point, any pyramid or cone, is the area of the base times the height, and then we just need one more step, divide by 3. And so when I look at this problem right here, I notice that it is a triangular prism. So the area of my base is going to be a triangle, which is just base times height divided by 2. So I'm going to do that real quick. Take my base and my height and divide by 2 of the triangle. And when I look at my base and my height, it looks like I have 6 and 8 would be the base and the height. They have to form a right angle. So I'm going to replace that with 6 and 8. And of course, 6 times 8 is 48. 48 divided by 2 is 24. So the area of my base is 24. And now I'm going to plug that back into the volume formula. Well, remember, volume is the area of the base, which was 24, times the height. And when I look at my height right here, that's from the center of the triangle to the very point of the pyramid. And it looks like that is a 9, so 24 times 9. And then I just have one more step, and that would be divide by 3. Remember, any geometric shape that comes to a point, and you're trying to find volume, the only difference between the formula for volume and something that comes to a point is just that dividing by 3. When I look at problem number 4, remember my volume is going to be the area of the base times the height. It comes to a point, this cone, so I'm going to divide by 3. When I look at this, my base is a circle, so the area formula for a circle is pi r squared. But I got to be careful because they're really not giving me the radius here, they're giving me the diameter. So the area of that circle is going to be pi times 3, which would be my radius, times 3 squared. And of course, if I leave that in terms of pi, it's going to be 9 pi would be the area of the base. I'm going to go ahead and plug that back into the volume formula. So the volume is going to be 9 pi, that was the area of my base. All of that times the height. My height is 8 inches. And don't forget to divide by 3. So it just becomes a calculator activity. When I move on, we have a center section of the handout, which is just basically using the distributive property and combining like terms. So remember, on problem number 13, I need to multiply a negative 2 times a positive 1. Well, a negative 2 times a positive 1 is a negative 2. Then I have to go back and multiply negative 2 times a negative 3b. Well, a negative times a negative makes a positive, and 2 times 3b becomes 6b. And that's as simple as it gets. I cannot combine those like terms, or combine those terms, I should say. They're not like terms. For problem number 14, remember, anything next to parentheses means multiply. So positive 4 times a negative 8x becomes a negative 32x. And then a positive 4 times a negative 2, that would be a negative 8. And once again, I cannot combine those two terms. They're not like terms. I'm going to move down here a little bit. 17, 18, these are just combining like terms. Well, 7k and a negative 9k, they are like terms. When I put them together, I get a negative 2k. Remember, I'm just putting together the coefficient. When I look at problem number 18, it looks like a negative 7p and a positive 5p are the two like terms. So when I put those together, I get a negative 2p. And of course, the positive 3 goes with nothing. So I just leave it there. Those two terms can't be put together. They're not like terms. So remember, the center section of the handout is just either using the distributive property or combining like terms. And the last part of the handout is really solving equations at a much higher level. And so I'm just going to do an example. I think I'm going to do problem number 28. And the first thing I need to do is use the distributive property. So 5 times 2 is a positive 10. 5 times a positive a is a positive 5a. All of this equals 4a plus 8. I want to combine, like terms, or at least I want to balance this equation. I want to get all the a's on one side of the equation. So I'm going to move them over here to the left. So I'm going to do a negative 4a and a negative 4a and just kind of see what happens. When I use my sum line, I get 10, and when I put a positive 5a and a negative 4a together, I get a positive plus a positive 1a. All of this equals, well, of course, those cancel, a positive 8. And of course, most students should be able to solve this equation from here, and I'm going to leave it at that. Well, maybe I won't. I probably should go on. I want to get a all by itself, so a negative 10 on both sides of the equation. So negative 10, and of course, when I put this together, kind of running out of room here, those cancel, so I have my positive a equals, and 8 positives and 10 negatives would be a negative 2. So I have one solution to this problem. This one a is a negative 2.